Bismillahirrahmanirrahim. Assalamu alaikum and welcome to another lecture on human factors engineering. Now we are going to start module 1, that is body-centered ergonomics, or we also call it physical ergonomics. So we have a number of topics to discuss in module 1. We will start with anthropometry. Anthropometry in workstation and equipment design. So this is a very important topic with respect to the design of workplace equipments and tools. So as we saw in the definitions of ergonomics in the very first lecture, that the ultimate goal of this course is to design. So this topic, anthropometry, helps us to achieve that. So these are the references that I have consulted to make the slides for this lecture. So I have provided you with most of these books. This is a textbook, the book by Helander and the book by Eastman Kodak Company, and the rules of our body space. So all these are very good books. So you can refer to them for more details. This lecture is further divided into 3 parts. In part A, we will discuss some very basics of anthropometry, the types of anthropometric data, and how we can actually collect that data. In part B, we will see some applications of statistics in the anthropometric design. So we will first review some basics of statistics and then we'll solve some examples. And in the part C, we will discuss some rules or some principles of anthropometric design. So part A is related to some basics of anthropometry. So learning objectives of part A include to identify the importance of anthropometry in human factors engineering, define and use some basic anthropometric variables, and differentiate between 3 types of anthropometric data. 3 types of anthropometric data, that is structural, that is also sometimes called static data, functional anthropometric data, and Newtonian anthropometric data. Just as a recall, in the very first lecture, we discussed 5 fallacies about ergonomic design. And in this lecture, we are going to discuss and address actually 3 of them. Second fallacy, third, and fifth. So in that discussion, we also actually learned that these are 3 most important fallacies out of these 5. The second fallacy was that design is satisfactory for average person. It will therefore be satisfactory for everybody else. So we will see why this is a fallacy. The third fallacy was the variability of human beings is so great that it cannot possibly be catered for in any design. But since people are wonderfully adaptable, it doesn't matter anyway. So we will see that we can cater for actually variability in the humans. And the fifth one was ergonomics is an excellent idea. I always design things with ergonomics in mind, but I do it intuitively and rely on my common sense. So I don't need tables of data or empirical studies. So we will see that data is a must for ergonomic design. So we will address fallacy number 2, 3, and 5 in this lecture. And we also saw that there are 3 elements of user-centered design, and most important of them is the user itself. So in this topic on anthropometry, we will be specifically focusing on the characteristics of user to design a product or task that is user-centered. So what is the definition of anthropometry? The word anthropometry means measurement of the. It comes from 2 words. One is anthropos, the other is metron. So anthropos means man, metron means measure. So it is about measurement of the human body. Anthropometric data are used in ergonomics to specify the physical dimensions of the work spaces equipment, furniture, clothing, etc. So that is why we are discussing it under physical ergonomics. It ensures that physical mismatches between the dimensions of the equipment and products and the corresponding user dimensions are avoided. So ultimate goal is to avoid mismatch between dimensions of the equipment products and the corresponding user dimensions. So use of anthropometric data in design. So these are the steps. This is a very important slide, and I would highly recommend you to understand these steps. So you have to follow these whenever you are going to perform a study to design something with respect to anthropometric principles. So step number one is to determine the user population. This is very important. You must be very clear for which population you are going to design the product. Second step is to determine the relevant anthropometric variables. So not all variables are required actually for every product. So one product you may require certain variables for yet another product you may require other variables. So you should be clear, you should list down actually the anthropometric variables that are relevant for that design. Then of course, if the population that you are targeting is small enough, you have to collect data on that population. Otherwise, if the population is large, you have to select a representative sample from that population. And based on that sample, you have to collect data of relevant anthropometric variable. And using the design principles, you have to design the product or workplace or equipment. And specifically, you must determine the percentage of the population that is to be accommodated and the relevant percentile value of the selected anthropometric dimension. So we will focus on these 2 points in a lot of detail in this lecture. So here the design is complete, but you have to actually check that design using simulation, using mock-ups, using prototypes, whatever is feasible, and see if the design is okay or not. And if it is not, then you will go back and make changes in the design and test it again, and this cycle will continue until you have reached the final design. So you have to keep these steps in mind, and these are very, very important. Types of anthropometric data, there are 3 types. Structural anthropometric data, that is also called static, because body measurements are taken while the subject is in a fixed position. Data are more easily determined, so much more static data are available. So we will see that there are different databases of different populations that are available for structural anthropometric or static anthropometric data. The second type of anthropometric data is functional. So this data relates to actually the range of movement of different body parts. And Newtonian data is related to strength and the strength of the population, the force that the people in a certain population can apply. And so here we do need some experiments actually to collect this type of data. So first we will see structural anthropometric data. Structural anthropometric data are measurements of the bodily dimensions of subjects in fixed or static positions. Subject here means individuals that are being studied. So measurements are made in either of the 2 ways. So from one clearly identifiable anatomical landmark, the reference could be anatomical landmark, or it could be a fixed point in space. So whenever you are taking measurement, there is some reference point from where you are taking that measurement. So in anthropometry, there are 2 possibilities. One is that you are taking the measurement of a body part with respect to another point in the body. And second possibility is that there is a point in space. For example, floor, for example, can be a reference point from where we are taking a certain measurement. Now we will see examples of both in one of the following slides. So use of this data relates to design of, for example, furniture and equipment. So some examples of the use of this data are to specify furniture dimensions and ranges of adjustment for that furniture, and to determine ranges of clothing size. And we will see some more examples as well. So this is the most common type of data actually that is required to design furniture, tools, equipment, and some wearable like personal protective equipment, gloves, etc. So here you can see different measurements are being actually not being taken, but they are shown here. So one of them is, let's suppose, the most common is actually the height. Height is being measured with respect to this surface. So this surface is, for example, floor. So this is the second possibility to define the reference point or reference plane. So that is outside the body. So this height, or that is also called stature, eye height, shoulder height, elbow height, all are measured from some reference plane outside the body. So this second point here. Same is true about seated dimensions. So we have, for example, sitting height, sitting eye height, sitting shoulder height, and knee height. So they are all being measured with respect to this plane. So that is a reference plane or reference line outside the human body. So there are some protocols as well when we will take these when we take these measurements. So for example, in both cases, see that in this case the person is standing erect, and in this case he is sitting erect. And for example, for measuring elbow height, elbow should be at 90 degree. This lower arm should be at 90 degree with the upper arm. And for example, for measuring knee height, the knee should be straight, making 90 degree angle with the thigh. So there is a lot of detail of these measurements that you can further read from the books that I have provided to you. The second possibility was that you measure a human body part with respect to another point in the body. For example, if you measure the hand width, so hand width is measured from this point to this point, and these points are actually specified in the books. But you can understand the first point here, that a measurement can be taken with respect to a point within the body. So this is the example of hand width. Another example, for example, could be this shoulder to shoulder width. Shoulder to shoulder width. So again, this is measured from this point on shoulder, outer point, and up to this point. So that is shoulder to shoulder width. So reference point is again within the body. And you can notice some other dimensions here as well. For example, this dimension, for this, the reference is again within the body as well. Now there are different ways actually to measure these dimensions. So generally these dimensions are taken using some calipers. So few of them are shown in this figure. So you could have calipers with just like a ruler you use, or they could be, for example, to measure specifically some width. Let's suppose you want to measure your width of your head, for example. So you could use instruments like these, or like this one. So there are different designs actually available. That is the point to be mentioned here. So that there are different designs of these calipers available. So according to the body part that you want to measure, the relevant caliper can be used. So limitation on the use of structural data, the first type of data. This type of data actually can be used in situation where people are adopting static postures. So caution should be used when applying these data to design problems that involve movement. So this data is very useful actually when you require uh, some products where the user will be in static posture for the most part. But if there is a movement involved and movement is a very important part of his activity, then you need a different type of data as well, and that is functional anthropometric data. And this type of data are collected to describe the movement of a body part with respect to a fixed reference point. For example, data are available concerning the maximum forward reach, and that is a very important type of functional anthropometric data, that is forward reach. How much in the forward direction can the arm of a person or of a sample of people can reach. Another example is the area swept out by the movement of the hand, that is also called workspace envelope or, or workspace zone. So that is something what we also discussed in once we discussed principles of motion economy in work study. So this enables to specify those regions of the workspace in which displays and controls may be most optimally positioned. So that is one of the actually example of use of this type of data. So they are useful for designing workspaces and positioning objects within them, particularly in the design of aircraft cockpits, the interior of the aircraft where, for example, pilot sits, crane cabs where driver of the crane sits, vehicle interiors, and complex control panels in the process industries. So these are very important applications of functional anthropometric data. So here are just two examples. One example is forward reach and the other is overhead reach. So this my distance from here to here that a person can reach is forward reach, and this is the example of overhead reach. So the height to which the hand of that person can reach above his head. So overhead reach this one and this one is the forward reach. And again, there is some protocol, some guidelines. Actually, there is a standard by ISO that details the guidelines to take these measurements. Here is another example of functional anthropometric data. Functional anthropometric data, the figure shows in here A is the allowable and P is the preferred zone. So preferably controls, and this, in this case specifically controls, should be preferably placed in this zone P. But actually that person can reach for those controls in the area that is marked as A. So A is allowed. Here easily the arm can reach, but E is more comfortable area to be reached. And in this figure, you can see this is shown in 2D, but you can find figures and tables and data actually of this area in 3D. So that actually sort of becomes a volume. So in front and back, in right and left directions, the figures and data are available. But this figure is showing it in 2D. So again, P is the preferred zone. Preferably the controls or the tool should be placed in this area. Here size is not shown, but in the table for different populations, the sizes can be found as well. The area of the zone can be found as well. And A is allowed. So that is the maximum range in which this person can move his hands. And we have already discussed this figure in work study. So you can see the work envelope is shown. So that is also example of functional data. So for example, uh, this NR, you can call it normal radius or normal reach for right hand, and this is for the left hand. So you can say this is the preferred area, and this MR, the maximum range, that is actually the allowed range. So this is for left hand and this is for the right hand, and there is some overlapping area as well. So this is also example of functional anthropometric data. So ideally, the tools and equipment that is used frequently should be placed in the normal range, and that is used relatively infrequently, that should be available in the maximum range. So here again, you may recall from the discussion on joints. For example, here it is shown pronation and supination. So range of movement of lower arm with respect to these two movements, supination and pronation, is from 80 degree to 80 degree on either side. So this is the neutral posture, this one 0 degree. So from this neutral posture, this neutral line on either side, we can move our lower arm up to 80 degree. So this concept of neutral posture is very important, especially it will come into play once we discuss different tools, ergonomic assessment tools for posture. In this figure, we are shown flexion and hyperextension. So again, if the arm is in the forward direction and we call it to be the neutral line, then hyperextension is possible up to 10 degree, but this arm can flex. This actually lower arm can flex up to this range, 150 degree. So you can, in a way, bend this lower arm, and you can complete your, rotate your arm completely up to 150 degree. So that is the range of motion of the arm. Similarly, your hand, this is the neutral posture of the hand. So you can flex the hand or your palmar side up to 80 degree, and you can extend it up to 70 degrees. So this is the neutral line, and you can move up to 70 degree in this direction, up to 80 degree in this direction. And in right hand and left position, this was up and down, flexion and extension. And if you are having your hand in this way, so this is the neutral line, 0 degree. So you can bend it 20 degree in the radial direction and 30 degree in the ulnar direction. So ulnar deviation and radial deviation with respect to this neutral line. So this is also example of functional functional anthropometric. Here is the example of your arm and shoulder in another view. So this is the neutral posture. You can adduct your arm up to 75 degree in this direction, and abduction is possible up to 180 degree with respect to this neutral line. And similarly, so this was, you can imagine it, this was in which plane? If you recall, this is in frontal plane. If we see in the transverse plane, so if we see the movement of arm in the transverse plane, so you can see we can move it from 0 up to 130 degree. And some extension is also possible. Right, so this is also in the frontal plane, so you can see that there is some backward extension that is possible, and forward flexion up to 180 degree is also possible. With respect to your cervical spine, that is your neck. So again, flexion and extension, this is the neutral line, so you can bend your head up to 45 degree in the forward direction, that is flexion, and 45 degree in the backward direction, that is hyperextension. And on the sides, you can again bend your head up to 45 degree, considering this to be the neutral posture. And same is about rotation. So that is up to 60 degree. And finally, another example of actually your functional data is this for your trunk. So again, this is the neutral posture, this frontal plane. So side bending up to 35 degrees possible, forward bending up to 80 degrees possible, and rotation on either side up to 45 degrees possible. So these type of data is very useful in designing the workspaces as well as the tasks to avoid the stress on the human body and musculoskeletal disorders as well. The last type of data is Newtonian data. So Newtonian means it is related to the forces. So it is used in the mechanical analysis of the loads on the human body, and the body is regarded as an assemblage of linked segments that have certain lengths and mass. So this data is used to compare the load on the spine due to different lifting techniques. So for example, data on strength of different populations is available. So this is just an example. You can find more examples from the books, especially the book by Eastman Kodak Company. So this is the data on strength for males and females for certain population. So for pushing forces, the mean strength for male and female is given if the handle height is 1.7. If the handle height is 1.3, so strength data for male and female is given. Same is about pulling forces and wrist twisting, and you can find the data for other types of forces that different people in a population can exert. And to actually find these strength values, you need to design some controlled activities. Select a sample of people from that population, ask them to perform those activities, and then you measure these values. So you might even be going for design experiments to find these values. So this type of data is useful, especially when designing the tool and equipment where force is to be applied, equipment or tool that is actuated using forces, for example. So here we discuss some basics of anthropometry and 3 types of anthropometric data. So if you have any questions, you can ask. Thank you very much.